Okay. So in the last class, we had completed with electricity. Just one topic we were left with. Everyone turn on your camera. And the last topic that we had to do from electricity is electrical energy and power. We had also started doing that. And in that process, we had done a few questions out there, right? Today, we will be doing the commercial unit of electrical energy. Okay. We will do commercial unit of the electrical energy, and then we will also perform some of the questions which are based on them. With that, we will finish up this chapter. And then from the next session, next class, we can start up with the, we can start with the question papers or sample papers of this, right? Or previous year question paper, whatever are available, we can start with them from the next session. So let us understand the commercial unit of electrical energy. Commercial unit of electrical energy. Live ना दोपहर में आओ. Commercial unit of energy. Okay. So for the commercial unit of energy, see generally we have seen the unit of energy that we use is joule. Okay. So what is the SI unit? What is the SI unit?
Joules.
Joule. SI unit is joule, right? So see, every time the SI units, they are not comfortable to be used. They are not suitable for all the purposes. Like for the SI units, we have meter as the SI unit, and we prefer using the metric system. But in the construction industry or in the making of the machinery, we generally do not utilize SI units. We utilize over there inches and feet. Yeah. We utilize inches and feet. So as per our suitability, we have designed certain units. Okay. See, joule is the SI unit, and if using this method, using this joule, we want to compute the energy consumed by a bulb. Let us just consume the energy, calculate the energy consumed by a bulb. Energy consumed by a bulb of energy consumed by a bulb of 60 watt. Okay. Or let's say just 10 watt bulb. I'm not even going to 60 watt, just have a 10 watt bulb in 1 hour. So how much of electrical energy is consumed by a bulb of power 10 watt in 1 hour that we want to compute in the SI system of unit. Okay. So as a, if you observe at your home, you must be, there must be around 6 to 10 bulbs which are glowing, right? And each bulb is of the power 10 watt only. So I am going to use how much of how many joules of energy are we using in 1 hour. Okay. So if I compute this by the formula, we know that power into time will be equal to energy, right? So this is the formula. Since obtained from this, power is given by energy by time or work by time. Okay. So power into time will be equal to energy. The power of the given bulb is 10 in the SI unit, multiply by time also in SI unit, which is 1 hour. So 1 hour is equal to 3600 seconds, right? So how much of electrical energy is utilized by one bulb?
3.6 into 10 power 3 joules.
Yeah, 3.6 into 10 to the power 4 joules.
Oh yeah, points. So yes.
Okay, so this much of electrical energy is utilized just by a single bulb. So, and that also of power just 10 watt. But at the home, you are using an electric motor, you are using a refrigerator, you are using a TV, you are using a fan, you are using a microwave oven. And if you compute that energy over a month, so you can expect the amount of energy that is consumed in joule, that will be in crores and millions. That is the amount of energy that you are using, joules. So unfortunately, this unit is not does not suit us. We does not want so many zeros in our calculations. So to remove that, we have a commercial unit, and that commercial unit of electrical energy is called kilowatt hour. Kilowatt hour is the commercial unit of electrical energy. So, or not only electrical energy, wherever we purchase energy, that energy we purchase or sell it in the form of kilowatt hour. Okay. So, if you are asked what is the what is the SI unit? SI unit is the joule. If you are asked what is the commercial unit, so that is kilowatt hour. And it's very easy. How we obtain the kilowatt hour? See, from the formula of energy only. Okay. From the formula of energy, since the formula of energy is given as power into time. So if you measure the power in kilowatt, if we measure the power in kilowatt, if I measure this power in kilowatt and time in hour, so the unit of energy consumed will come out to be kilowatt hour. Okay. So what is the energy of 1 kilowatt hour? Let's see. Let's understand what do we see. What is the energy as 1 kilowatt hour? So energy will be written as power into time. And I just said that you have to take your power in terms of kilowatt and time in hour. So the energy consumed will be kilowatt hour. Okay, see. So just obtain the energy can be computed if you have the power rating in kilowatt and time in hour. So that energy will be consumed as 1 kilowatt hour. So you can say what is, if you ask what is 1 kilowatt hour. So if a device, or you can say energy consumed by a device of power 1 kilowatt in 1 hour. Okay. So you can write something like this, that energy consumed by by a device, energy consumed by a device in by a device of power 1 kilowatt 1 kilowatt in 1 hour. Okay, is called is called 1 kWh or 1 kilowatt hour, or so this is 1 kilowatt hour, or we call it as 1 unit. This is also called as 1 unit. Okay, unit is the SI unit of unit. We also call kilowatt hour. It is also read as unit. So do not confuse it. If you are given 30 units, so 30 units means 30 kilowatt hour. Okay. So I think now you understand how we can find out the answers to this. Okay. So let's do a small question just to understand this. So You have to find the energy consumed, or let's say find the energy consumed in kilowatt hour by if following devices are used.
Sir, I think you are muted.
No, I'm not muted. I'm just writing the question and
Oh, okay.
you okay. So you can start solving this. You have 5 bulbs of power 8 watt run for 6 hours a day. Then two fans of power 40 watt run for 18 hours a day. A refrigerator of power 350 watt run for 18 hours a day.
Sir, like the 5 bulbs and the 2 fans, sir, together they are 8 watts or each of them are 8 watts?
All the bulbs they are run for 6 hours per day. Two fans, so two fans, both of them they run for 8 hours per day.
So
Okay.
each of them are 40
The
40 watt?
yeah, 5 bulbs of power 8 watt each. Similarly, 40 watt each. Okay. So I think I'm giving you 5 to 5 minutes. If you people are able to solve this, so well and good. Otherwise, I will show you how to solve it. Just use your mind. If you are able to see, solve it. I'm giving you the hint. You have to convert your power to kilowatt. Use your power in kilowatts and time in hour. Okay. Use the formula. Use the formula. Energy will be given by power into time. Okay. So is there anyone, Mehak, are you able to get the problem? Do you need any help?
Yes, sir, I'm trying, sir.
Okay. See, the power of one bulb is 8 watts. So you need to compute the energy of one bulb, then energy of 5 bulbs.
Sir, I computed the energy of 5 bulbs at a time, sir.
That will be same. Okay.
Oh, okay, sir.
It will come out to be same. नहीं लगी वो, पत्थर पत्थर नहीं लगी वो. Okay, so I have got some of the answers. Tanishka. See, I want for all the devices and for 30 days. Okay, so first you compute for one device for one day. Tanishka,
Got it, sir. I'll do it for 30 days now.
yeah. And I think you have computed only for one device.
Yes, I just realized I multiplied it into 5 and I'll send you the answer again.
Okay.
Sir, I also sent.
Okay. Let me check out. Mm, yeah, Dhruv has sent answers. So what will be the total energy consumed, Dhruv?
Sir, by all three together.
Yeah. I think Dhruv has sent the answer. I'm expecting answers from other people also. Mehak, Vedika, Medha, Ansini, are you getting? Silasia, you are not responding during the class.
Sir, I'm responding, sir.
Okay, so have you got the answer?
Sir, still trying.
Okay, so are you finding any problem?
No, sir, I'm still confused little. Like these types
Okay,
of problems.
confused with, okay, so confused with what part?
Sir, like solving these types of problems, I'm losing marks in it.
Okay, so I make it clear today. Okay, just I'm solving it. So everyone
So
see,
even I send
I'm
the answer, sir.
okay.
Yeah.
So no issues. Some of you are able to find the answer, some of you are not able to find it. So just see how we compute this. Okay, first of all, we compute for each device. Okay, energy consumed by each device. Okay, Hasnita, Amatur Rahman.
Yes, sir.
Okay,
Yes,
so I
sir.
think you are also facing some of the issues over here.
Yes, sir.
Okay,
Yes, sir.
see, first, how do we go about? First of all, you compute energy consumed by each device. Energy, first I'm going by bulb. I'm going by the bulb. So energy consumed by one bulb. Energy consumed by one bulb in 30 days. Okay. So what will be the energy consumed by one bulb in 30 days? This will be equal to the power into time. Power is 8 watt. So power is 8. And what is the time in 30 days? In one day, it is running for 6 hours. So in 30 days, it would run for 6 into 30. Yeah. So Hasnita and Srilasya, is this understood up to here?
Yes, sir.
Yes, sir.
But see here, the power was given in watt and we have put here. But according to our rule, we have to put the power in kilowatt, right?
Yes, sir.
So to convert this watt to kilowatt, we must divide this 8 by 1000. Okay, so we divide this 8 by 1000. Why did we divide this? So either you can go like this. See, there is another way. Instead of dividing here by 1000, what we can do, convert all the powers to kilowatt. Like this is 8 watt, convert it to kilowatt. So this would be 0.008 kilowatt. Okay, convert this 40 watt to kilowatt. Yes.
Sir, or can we like find energy first, all of those energies, and then divide, adding all of those and then dividing it by 1,000?
But that gives some a wrong interpretation. Okay, somewhere we are going wrong in that case. Why we are going wrong in that case? As we will be getting the unit as watt hour.
So what if we multiply like 5 into 8 and then we get 40. So
Yeah.
40 plus 80 plus 350 by 1,000.
What you are saying? Pardon, please.
So 5 into 8 is 40. So 40 plus 2 into 40 is 80. Plus 80 plus 350 by 1,000. Can we do that?
Yeah, you can do that also. Once you understand the basic thing, then you can shorten your calculation. You can adopt various methods. But okay, once you understand what we are doing over here.
Okay, sir.
Okay. So see, energy consumed by one bulb. So for this, we must use the power. So we have converted the power in kilowatt, which is 0.008. Multiply by the time. The time is 6 hours. So in one day, it consumes this much of energy, and in 30 days, it will consume an energy which will be multiplied by 30. Okay. Now, what will be the energy consumed by 5 bulbs then?
Into 5.
Into 5. So is there anyone who is having any problem with this expression? Tanishka, Hasnita, is there any problem with this expression?
No, sir.
No, sir.
Amatur Rahman?
No, sir. Understood.
Okay. So just multiply these and see you get the answer. That is the energy consumed by this bulb. Okay. So multiply 5 times 0.008, multiply 6, multiply 30. So you get your answer as 7.2 kilowatt hour. Okay.
Sir, to
So for
make
the
calculation easy, so we can do like the cutting part and all those also, right, sir?
generally I do not prefer cutting part. Okay. Rather I
And
prefer
still I got the same answer, sir. 36
you
divided by 5, I get same thing.
you will get the answer. Instead of cutting it, you multiply it and put the decimal.
Right, sir.
Okay. See, anytime if you have 10, 100, 1000 such numbers in the denominator, do not go by cancelling. Just put the decimal in proper order after multiplication. Okay.
Yes.
And see how you can simplify the multiplication. Like here, you should multiply first 8 with 5. So 8 with 5 will give you 14. So that becomes 0.04. Multiply that 4 by 3. So 4 with 3 will give you 12. And 12 with 6 will give you 72. Understood?
Yes.
Okay. So if you are confused with this decimal, remove the decimal, put 1000 in the denominator, multiply everything, and then put the decimal at its proper place. You will get your answer. So I don't think that anyone has doubt over here. Now for the second one, you have two fans of power 40 watt each. So second one we compute here. This energy will be, we change this 40 watt. So energy will be equal to 40 by 1000 multiply 2 multiply 18 hours, and it is run for 30 days. Okay. So if you remove the zeros, just remove the zeros. So two zeros are removed. Then you can multiply the remaining. 2 into 3 is 6. 6 into 4 is 24. So you can multiply 24 and 18 and put 10 at the proper place. Okay. So what will be the product of 24 and 18? It's 432.
108 something. No, no, no.
No, it's 432 and it will be 43.2 kilowatt hour. This is for the second one. Similarly, we obtain for the third one by converting this 350. So it would be 350 divided by 1000 multiply 18 multiply the number of days, that's 30, and it is only one refrigerator, so we can multiply it with 1. So
Sir,
again, yes,
sir, upon the multiplication of 2 into 18 into 3, sir, we get 108.
2 into 18 into 3.
Yes, sir.
So 4 into 2 is 8, 8 into 3 is 24, and 24 into 18 is 432. Check your calculation. So you are getting 432 only. That's 43.2.
All right, sir. I mistakenly forgot to multiply 4 and that.
Okay. So here you can multiply directly, or as you can see, if you cancel it out, so you have here 5 7 times, 5 2 times 2, here you have 9 times, and then you get your answer, which will be 21 multiply 9, which is 189 unit or 189 kilowatt hour. Okay. So we have computed the energy consumed by each device. Now, what will be the total energy consumed then? Total energy should be 189 plus 7.2 plus 43.2. Okay. You add this and you get your total energy. You get 239.4 unit or 239.4 kilowatt hour. So now we do not have such long decimals and we have a proper value. Okay. And suppose if in your area, the cost of electricity, suppose the cost of electricity is or electricity is charged at the rate of rupee 6 per kilowatt hour or rupee 6 per unit. So we can also compute the cost. So cost of this energy will be 6 multiply 239, 239.4. Okay. So I think almost everyone has understood. If anyone is having any problem, so the person should speak up in this question if you are having any problem. Otherwise, next question, if I give, I'm expecting answers from everyone. Yeah, Shesi has given the answer. That was correct. Tanishka gave the answer. Dhru gave the answer. Amatur Rahman, your answer was incorrect for the first one and correct for the remaining two. Tanishka. Okay. Dhruv, who has Hasnita had not sent the answer. Trilasya
Yes.
had not, and Medha Hansini did not send the answer. So Mehak also did not send the answer. Manan.
Sir, I checked my answer. I got wrong answer.
Okay, so that is
Sir,
what
one
I am
I got
learning.
wrong.
Okay, so even if you are getting wrong, you should send it to me. And so first of all, have you understood Mehak, Manan, Trilasya, and Medha Hansini?
Yes, sir.
Yes, sir.
Medha Hansini, I'm not getting your reply. Understood or still confused?
So first and second I understood, but third one I'm feeling that.
So for the third one, that means for the refrigerator.
Yes.
So it's the similar thing. What is the difference? You convert your power to kilowatt and multiply it with time. Power is 350. Convert it to kilowatt. 350 divided by 1000 and multiply it with time. Okay. So time is 18 into 30. Okay. So let's see and solve another question. Let's do from NCRT. Okay. And I think you people might have solved that question from NCRT. Okay, just solve this one. Solve the example 12.13. Solve these two questions. Let's see if you are able to compute it. Okay, so I have got one answer, 2. Okay, so Mathur Rahman, you gave the correct. Okay, Mathur Rahman has given correct answer. Manan has also given correct answer. Mehak has also given correct. Okay, so this question, I think everyone has given correct answer. Two 288. Okay, fine. So the answer is 288. Okay, let's see if you have any other question.
Sir, can you explain question 17?
Question 17.
Exercise.
Question 17 of exercise. Okay, I'm moving to exercise. Wait. In the last class, we had done question number 4. We had done, right? We had done question 4?
Yes, sir, we had answer.
Okay. Question number 5 and 6 you can practice on your own. 6 you can practice on your own. There is just calculation. Question number 7 you shall do. And question number 8. Which question you are saying? Question 17?
Yes, sir.
Okay. See, an electric heater of resistance 8 ohm draws 15 ampere from the service mains 2 hours. Calculate the rate at which heat is developed. Okay. So what is asked in the question? Just read the last line, what is asked. Yeah, what do we have to compute?
Sir, power.
Power. Okay. The rate at which heat is developed is also called as power. And what's the formula of power? What are the formulas of power? We can compute power as V into I. We can compute power as I squared R, or we can compute power as V squared by R. So in this case, which one will be the correct one to use? We know the current that is drawn, right? We know the resistance that is drawn. So which formula shall we utilize?
I square R.
I square R. So we have the formula I square R. So I is 15. We get 15 squared multiply R, which is 8. So 225 multiply 8. That's the answer. Okay. So you get 18.
1800.
Yeah, 1800 watt.
Sir, rate of doing work is power. It's mentioned in reader. Rate at which heat is evaporated also means power, sir.
Yeah, rate at which heat is evolved. Heat is energy and work and energy, they are equivalent.
Okay, sir.
Yet time was of no use, right, sir?
It's of no use, just given to confuse. Okay. Yeah, the time could have been used if they say 15 coulomb of charge flow through the service main in 2 hours. So then, of course, okay. So I think there is no doubt in this question.
Yes,
Okay.
sir, clear.
So I think what questions are important from here? First of all, all the questions starting from here. Let's do question number 8. Let's do question number 8 and solve the answers.
So question number 14.
Question number 8, starting from question 8. We are
Okay,
going
okay.
in the sequence now.
Okay, sir.
Okay. So as quickly you solve, we will move to the next problem. Yes, so there is just one thing to do in this question 8. I'm expecting answers. I have not got any answers. Hotel mall से कम बात करो. Hospital mall से बात करो. Okay, so just I received one answer. A very simple question this is. Only Shreyasi has given the answer. Amatur Rahman has given the answer. Okay, fine. Manan also gave the answer. Okay, so I can expect the answer as from everyone. Tanishka, what's your answer?
Sir, I got 4,800 ohm.
Okay. Srilasya, what's your answer?
Where I'm rechecking it, I'll tell you in a minute.
Rechecking it. See, the problem was that, see, it has a small answer. When a 12-volt battery is connected across an unknown resistance, there is a current of 2.5 milliampere in the circuit. Find the value of resistance. So you have to use the formula V equals to IR. Therefore, V by I will be equal to R. V is 12 divided by I, which is 2.5 milliampere. So it would be 2.5 into 10 to the power minus 3 ampere. So the point was just conversion of this milliampere to ampere. Convert this 2.5 milliampere to ampere. It will be 2.5 into 10 to the power 3 minus 3. And then transposing it to the numerator, you get 12 divided by 2.5 multiply 10 to the power 3. So this will give you 4.8 multiply 10 to the power 3 ohm, or you can also write it as 4.8 kilo ohm. Ajio में काट में. दो तीन चीजें और करता है कर लो. हाँ जैकेट के लिए फिर अब करो. Okay beta, so I think this one everyone has got. For the ninth question, I think you can do ninth question as homework. Let us do question number 10, 11. And currently we will do question number 11. Then after that, before going, we will be solving question number 10. First, let's solve question number 11. So apply your minds. Show how you would connect three resistors, each of resistance 6 ohm, so that the combination has a resistance of 9 ohm and 4 ohm. Okay. To obtain resistance of 9 ohm, how do we get this? Just by using this concept that in the series combination, so in series combination, resultant resistance is greater than greatest. I think Medha Hansini is not confident with this chapter. She seems to be unconfident. Yes?
Sir,
Uh, you do not seem to be much confident with this chapter.
sir, only numerical, sir, particular.
So this chapter has only numericals. Okay. This chapter and light, it has only numericals. Okay. So that is why we are here. If you are facing any issue, do not hesitate to ask. If you ask, your doubt will be clear. Okay. So in the series combination, resultant R is greater than the greatest. That means if you combine all 6 in the series, so your answer will be always greater than 6. Okay. So suppose you want the answer as 9 ohm. So 9 ohm is greater than the 6 ohm, right? So therefore, I must use a 6 ohm resistor in the series combination. So here I must use a 6 ohm combination, and here now I must use other resistances in some way so that their equivalent should be 3 ohm. So Manan, how can we connect them to obtain equivalent resistance of 3 ohm? You have 3 resistances, you have 3 wires. Okay. You have these 3 wires, each of resistance 6 ohm. So out of these 3 wires, one wire I have utilized over here. I have to use these 2 wires to obtain an equivalent resistance of 3 ohm so that they will produce an equivalent of 9 ohm.
So to get 9 ohm, you can do 2 in parallel and 1 in series.
Yeah.
So for 9 ohm, you can do 2 in parallel and 1 in series.
Yeah. So if you get here 2 resistances in parallel like this. So in the parallel combination, if this is your 6 ohm, this is your 6 ohm, so equivalent you will get your 3 ohm. and 6 plus 3 becomes 9. Now the shortcuts. See, the shortcuts are helpful here. The shortcuts that in the parallel combination, hmm? So in parallel, you have this R equivalent is given by R by N. If there are two resistances, so R equivalent will be R by 3. If there are three resistances, so it will be R by 3. So in that way it goes on. And in series combination, in series, R equivalent is given by N into R.
Sir, what is N here?
N is the number of resistance. Okay. But this is applicable only when all the resistances are equal. Okay. If all the resistances in series are equal, if all the resistances in parallel are equal, then only we use this formula. Okay, so how you will get the resistance of 4 ohm? Since 4 ohm is less than 6 ohm also, so you cannot connect any of them in the series, right? And you have only 3 resistances. So